Alright y'all, well I am back potentially with another repair video. So just got this in the mail. This is a HP 6038A power supply, 0 to 60 volts, 0 to 10 amps, 200 watts. Got this thing on eBay for like 50 bucks. It was listed for parts repair, so I knew it was not working. Got it for, well, the first reason I got it is I don't have a power supply that has this much output. So the power supply I have currently that the most output is this singlet, which I really like. It's that does a max of 32 volts and up to 3.2 amps. So that's roughly 90 watts. So this guy's more than double that output. And then another thing was it is displaying a very weird symptom. So when you power it up, all of the indicator lights and all the 7-segment LEDs just are, everything's on. Nothing really responds to any of the buttons. Actually, I don't keep it on long enough to even try that, because another thing that happens when you power it on, there's definitely a very pungent smell, magic smoke smell. So, you know, the smell of burnt semiconductors, it's a very characteristic smell. So that starts emitting from it immediately. You don't see any smoke, but the smell is very apparent. So I shut it off. You know, I only leave it on for a few seconds and then I power it off. And I can show you that, guys, in a sec. But yeah, so you know, we're gonna take a look at this, see if we can get it running. But yeah, let's power it on so I can show you guys what's going on here. So here we go. Okay, so yeah, and already that smell is starting. So yeah, that I can already smell it. So yeah, that's what we're dealing with. Yeah, why don't we get it open and see what's going on? Okay, so I got the top panel off, and no signs of anything yet. I mean, everything is still pretty much enclosed here, but you do see a RIFA cap, all cracked on the outside. It doesn't look like that's the issue, but RIFA madness. So yeah, there's that. Very cool here. You got all these trimmer pots. So I guess for calibration, which I think is neat. Yeah, you got this side of a board here. So nothing. Not finding the source of the smell yet. We're gonna have to keep digging. Okay, so we've got this metal cover off, and which has revealed a lot of the unit. First thoughts, this is a lot more complex than the last power supply I worked on, which was that E3612A, or at least it looks like it is. You've got multiple boards. Yeah, in fact, that E3612A is the only linear lab power supply that I've tried to repair. So yeah, this is a whole different beast. And you know, at first glance, everything, I wasn't able to find anything, visually at least, that looks suspect. I mean, it's very dusty. that's for sure. But you know, I was looking at all the boards. Nothing was really jumping out. Nothing on these heat sinks. I mean, let's see here. Now there's some big either TO3 transit. Or no, those look like MOSFETs, I believe. Maybe. International Rectifier usually makes MOSFETs, but yeah. So these guys, there was a ton of dust on those. So I was thinking maybe one of those is, but nope. But I did finally see something that caught my eye, and I'm not sure if it's going to come up on camera because it's way down there. Can you guys see that? Come on, focus, you. Yeah, you're not going to be able to see that. All right, hold on, let me see. Let me grab a flashlight. Hold on. All right, so can you guys see that now? Come on, focus, bud. Yeah, there it is. Look at that. CR7 and CR6, those diodes. Now, I can't get the flashlight at the right angle, but the CR7 is like almost cracked in half. But there clearly looks maybe some damage to CR6 as well. So that is definitely where that smell is coming from. I said that characteristic semiconductor burnt smell. Yeah. So I think that's our culprit, at least for the smell. So whether or not that's the primary fault or some sort of secondary fault, it's still way too early to tell, but yep. So we're gonna have to get down in there and access that. I'm also gonna see if there's a schematic available for these. Fortunately, with these, you know, HP equipment, if it's old enough, and I believe this one is, you can usually find, well, HP is no longer, HP is now Agilent, so yeah, for most HP equipment, or that's labeled HP, you can generally find schematics for them still. So let's take a look online and see if we can find out what CR6 and CR7 are doing. So I was able to find the service manual for this power supply online, which is great. You know, as I was saying, looking at the supply when we opened it up, it was kind of clear that this supply is a bit more complex than what I'm used to working on or what I've worked on in the past. You know, because it's got more boards. It just looks more complex visually. Also, looking at the service manual, you can tell it's more complex because it's 185 pages long. So it's a longer service manual as well. Yeah, so I was kind of just reading the description of this supply. I've never worked on one of these before, and I've never used one of them before, so I just kind of want to start it from the top. But one of the things that caught my eye, even when I was looking at the supply, the label, so it says it's 0 to 60 volts, so max voltage is 60 volts, max current is 10 amps, but the max output is 200 watts. So I thought that was interesting because usually when you see max voltage and max current on a supply, you just multiply them together and you have the max output. So we're not seeing 600 watts as the max output on the supply, it's 200 watts. So, you know, I was curious as to why that is, and I was hoping to find that in the service manual, and sure enough, in the description, it mentions right off the bat that it is an auto-ranging power supply. It uses power MOSFETs and a 20 kilohertz switching inverter to provide an auto-ranging output characteristic. Now, I had never heard of an auto-ranging power supply before until today, so I had to look up what that meant. And found this article on electronicdesign.com that explains what auto-ranging power supplies are. And so they do it with these graphical representations of volts on the y-axis and current on the x. And so, you know, here you can see that a regular power supply has this rectangular representation. Okay, so, you know, at max volts, max current, you just multiply them together and you have your max watts. And now with a auto-ranging power supply, the graphical representation is a bit different. Okay, so this slope of this line is the max voltage that you max output that you can achieve for the power supplies. You're adjusting the settings. Okay, so they use in this example a 50 volt max 50 volt supply, max 10 amps, and max watts is 100. So ours is a bit different. They also call this a 5-to-1 auto-ranging supply. Ours would be a roughly 3-to-1 auto-ranging supply. So just an interesting thing. I'd never heard of an auto-ranging supply before, but it also explains why they're more complex and they've got more boards, because the power supply is constantly trying to calculate to make sure you're not exceeding that max output. And so this actually has some advantages, it has some disadvantages, so kind of goes over that a bit. And you know, here's an interesting representation. So for example, each of these rectangles within this sloped graph is an example of a power supply. So you can use auto-ranging power supplies to kind of you know, they have a wider range, basically, is what this article is trying to say. And they also have disadvantages as well. They're less accurate due to the fact that they are constantly, you know, calculating that output. So you lose some accuracy there. But yeah, I just thought it was pretty interesting. But yeah, let's try to move on to the schematic. Okay, so it took me a while to find some information on this. The service manual, well, it's both the service manual and operating manual for this supply on Keysight's website is, you know, this is the 185 page one. I mean, I can't read any of that. It's really difficult to make out. Okay, so not going to be helpful. And, you know, just for reference, I believe that's CR7 there, and then I think CR6 is up there. Okay, but we can't read that, and that's not going to work. So I was able to find just the service manual on just by Googling. And so it has this section, troubleshooting the bias supply. So this measurement here for the plus 5 volt bias supply, it has this measurement here, 20 volts, and then CR6 and CR7. Okay, so those are the two diodes that we were looking at that look charred, pretty much. And you know, then there's these other bias voltages, plus 15, minus 15, some waveforms to test. I mean, this is awesome. All of this information that you got, the minus 15, and there's two more, 8.9 and then 2.5. So you have these 5 bias voltages that are from this power supply on the main board. And so we can look down at the schematic. Let's see. Sorry about that. We're almost there. I mean, there's just so much information, and look how much clearer this one is. Just this was definitely going to be the one I'm going to be referencing for this repair. Yeah. Okay. So this is what we want. So again, here's CR6, and then CR7 down here. Alright, so then there's your plus 20, and that goes to the control board, and there's your plus 5 there. So it looks like these diodes are involved in some sort of rectification of that 20 volt signal, which then gets, then becomes your 5 volt bias supply. So yeah, so that's at least some of what these guys are involved with. I'm sorry, C6 and C7. So yeah, definitely part of the bias supply voltages. So what I like about HP is they build these to repair them. All right, so these boards should just easily pop out. All right, you can see the connectors down there, so we should be able to get this out. And the same goes for this board, which I believe is the actually, I'm not sure which board that is. This is the control board. Yeah, so this board though also will pop out, and that'll give us a lot of access to the main board on the bottom. So let's start popping these out and see if we can get a closer look as to what's going on. Alright, so it's looking a little bit more bare now. We got most of the boards out with the exception of the main board, obviously. But yeah, so we've got, this is the control board here. The GPIB boards, and then the power mesh board, and the front panel board is still in there, and this is the main board, and you can see those diodes in all their glory. Look at that. Wow. I mean, that's some carnage right there. Yep. Still really curious to see if this is a primary fault, or if this is, a secondary fault. This is now that I've gotten a much closer look, this appears to be the only visually, visual issue that I can see. But yeah, look at these really cool power resistors. I've never seen make like that. They just have an interesting, they got that 3-leg, just an interesting look to them. And I mean, of course, yeah, we've got the RIFA caps that are looking a little bit cracked, but I'd be willing to bet those probably still test fine. But yeah, it's getting late though, so I think this is as far as I'm gonna get for now. And then, we'll might come in. It's Friday, so I might come in this weekend to work on it. I'm not sure. We'll see. But yeah, so I'm gonna stop here, but we'll continue on this guy. Get this main board out and make sure these caps are discharged. Everything else is fairly lower voltage, but well, at least as far as the electrolytic caps. But yeah, so we're gonna be careful with those, handling those, discharge them, and get this board out so we can get a closer look at these diodes. Alright, so we've changed scenery here. I've brought the supply to my home, and I've got it out of the board so I can removed those dead diodes. But at home there are distractions, and so I'm actually right now working on my partner's Novo vape, nicotine vape. Uh, it had a bad, one of the leads to the charging port had fell off, so I'm resoldered it and now I'm charging it. We're gonna see if it works, but yeah. So we'll get started on this after that. Okay, so we got those two diodes out, CR7 and CR6, and you can see there's a pretty good deal of damage to the board. I think it should still be salvageable without any additional work, but definitely maybe some more cleaning. Whatever this short that occurred definitely ate into the you know, the actual board, but anyway, yeah, we'll have to see how viable that is. The diodes themselves had a just a few numbers on them, or at least the one that I could read. They are the same. A 10. Let me see. Yeah, it's a 10, 731, and then 8747 on it, which really wasn't all that helpful. But the service manual just says that they are, looks like, yeah, 400 volt, 1 amp rectifier diodes. So I do have something that should work. These 1N, you see, 1N 4937 diodes. So those should work just fine. It's actually rated for 600 volts and 1 amp. So that should handle our needs for this. I'm going to pop them in and then we'll go from there. Okay, so I've got those two diodes in, CR6 and CR7. You know, I did some other testing. You know, for example, I checked all those big electrolytic caps with my LCR meter. They all seem okay. Checked for continuity, where there should be continuity for where those diodes connect to, and everything looks good. Just given that these the holes where they, you know, they connect are just in really bad shape to the board. So, but everything looks good there. And so, you know, the one thing I don't like about this supply is that you can't really test the boards. You really just need them standing vertically attached, it looks like, to the main board, you know, which can kind of make things difficult for probing and stuff. So yeah, I think that's what we're just going to do next, because in order to check all the bias voltages, most of those test points appear to be on A2, which is right there, that board, the control board. So I think I'm going to put everything, connect all the boards, put it back in the chassis, and see what happens. Alright, so before I put everything back together and powered it up, I just wanted to take a look at the front panel board, because it, you know, it does have some old school buttons on it, and I just wanted to clean them up, and I also wanted to clean up this pot with some contact cleaner. And yeah, one thing I noticed though is these button switches are kind of unique. I haven't seen switches like that before, and it looks like this metal strip is just a spring to give it some spring action, so it pops right back up after you press it. So I thought that was just pretty neat. I hadn't seen switches like that before. But yeah, I'm gonna make sure the contact cleaner. The excess has been either wiped away or evaporated before I power it back on. But just wanted to show you guys that. Alright, so I've got the thing pretty much back together, so we can do some testing, see how if it powers on. And now initially I was just gonna, power it up normally using an isolation transformer, of course, but I actually, the service manual provides a setup that you can do for troubleshooting. And so this is the kind of the diagram that's in the service manual. So first, they've got they've got the isolation transformer, but it's not hooked up to the mains out input. Okay, so they have it connecting the secondary side of the isolation transformer to test point 1 and test point 2 on the main board. There's also a switch by those test points that you can switch from normal operation mode to test mode, so that switch is put into test mode. This connector there, A2, J3, so that's on, A2 is the control board, so J3 is the connector where we are going to be doing most of the probing for test points. And so then down here, you see they've on the power receptacle, they've got a DC power supply hooked up to it. And so the reason for that is by connecting to your isolation transformer mains to these two test points, it does power up the bias voltages, which I'm interested in testing because that had to do with those two diodes there, the 5-volt bias voltage. But so it actually it does fire those voltages up, but it doesn't connect to the input rectifier and create the bus voltage, which is at 320 volts DC. So by connecting the DC power supply to the AC receptacle on the back, the unit is acting as a DC to DC converter. And so you have more control over the bus voltage that will be going across the PFETs on the A4, the power mesh board. So if there's a defect on the power limit comparator or the off pulse circuitry, you're not going to do as much damage. So that's the reason for that. Okay, and then I guess there's also these dip switches need to be set accordingly. And then last is they've got this 50 ohm 10 watt resistor across the outputs of the supply. Okay, so that's the setup for troubleshooting. Now I've tried to do that the best that I can. So got the isolation transformer. So that is connected to test point 1 and 2, and hold on, let's see. Yep, and so we've got that switch there in test mode, and then we've got our power supply hooked up to well, it's not. I don't have the receptacle connected, but that's where the line and neutral connections go, right there. All right, so that's where our DC power supply is. Now I don't have a 40 volt power supply. This goes to a max of 30 volts. But it looks like for a lot of the testing that we are going to do, we may not even need the power supply hooked up. So at least for the bias voltage testing, you don't need it. We'll see how far we get, but so I'm not too concerned about that. And then on the output, I've got I don't have a 50 ohm 10 watt resistor. I think that's a 60 ohm, I think 50 watt resistor. So that's the closest thing I've got. And I think I still need to set the dip switches correctly for testing. So this is the setup, and let's give it a try. So I'm gonna make sure those dip switches on the back are set properly, and then we'll give it a go. Alright, so it looks like those dip switches were set correctly. I didn't make any adjustments, that's just how they were. I'm not sure if they're always like that, or, if you do need to make changes for this setup. It doesn't specify in the service manual, At least I didn't see. But let's fire this guy up. Now I did disconnect the when I did remove the front panel board, as I was saying, for a number of reasons. So I think I connected the power switch back correctly, but what I'm saying is that it may automatically come on by flipping on the isolation transformer. We'll we'll find out in a second. So let's give it a whirl. Okay, so I guess I did connect it properly, or something else is horribly wrong. But yeah. All right, here we go. Interesting. And I am starting to smell. Yep, something is smoking. Okay. Yeah, something was just smoking. Oh yeah. Whoa. Jesus. Yeah. So, yep. Clearly there's still some type of issue here. Because those diodes are going right back up in smoke again. Oh man. Yep. Okay. Interesting. Okay, so I was wanted to see if I could narrow down where this fault was coming from. So, yeah, as we saw, clearly the board was started releasing the magic smoke from those diodes, CR6 and CR7. And so I immediately turned it off. And then I wanted to start removing some of the boards to see if it would stop if I removed one. And so I removed the control board, and it stopped smoking. So it seems to be that there's an issue with that board, but I just wanted to kind of take it a step further to see, if the main board is providing that unregulated 20 volts. So right now I've got some jumper wires connected to pins 15, 17, and 19 on that connector right there. If we take a quick look at the schematic, let's see. Yeah, so so pin 15 plus 20, and then pin 17 is the common for that run regulated supply, and then there's the mains detect pin as well. So right now I've got my scope out, probing pins 15 and 17, which is that 20 volt unregulated supply, and you can see this is what we should be getting. So it's rectified 20 volt supply. So that's good. So the issue doesn't appear to be with the main board. It's something going on with the control board. So we're gonna have to take a closer look there. Another thing I wanted to point out before we start taking a closer look at the control board is when I probe CR7 and CR6 with the board removed, you can see, you know, the forward bias voltage across the diode just fine. But watch what happens when I plug the board in, the control board, into the main board. Okay, so now I have the the control board attached to the main board, and let's probe that diode again. Okay. So now they're both reading short, which explains why they are burning up when the control board is plugged into the main board. So that makes sense, but we need to figure out why that's happening. Now, I did probe on that J3 connector, which, see if I can get that. Yeah. So that is that connector right there. That's the J3 connector, where during the troubleshooting that you would be able to probe that connector for a lot of test points. And so it has the regulated bias voltages, the plus 15, the minus 15, the plus 5. I did probe those and did not see any shorts across them. So something else on this board is causing that diode to be short, and we're gonna have to figure out what that is. But not as doesn't appear to be as clear as I thought it would be. So yeah, we'll see what we can find on the control board next. Another thing, so if I put a jumper wire between pins 15 and 17, which is across the 20 volt unregulated supply, look what happens. Okay, so it appears that we have a short across that supply on the control board. So we can take a look at the schematic and see what some likely suspects might be. Okay, so here's the schematic again, and so again 15 and 17 on that connector is the incoming 20 volt unregulated supply. So you can see you've got this electrolytic cap C23 that's across the supply. That could be a problem. Yeah, I think that would be the first one to check. There's yeah, I think we'll check that first and just kind of move on down the line. Well, I think we found the culprit. So we got a dead short across this capacitor. This is C23. So I think that's our issue. And you know, this is actually a 3-terminal cap, so you know, this is your positive lead, and then you have 2 negative leads, so these will be at the same potential as well. That's normal, but definitely not, this definitely isn't. Yep, let's hook it up to the LCR meter just for fun and see what we get. Alright, so we have it hooked up to the LCR. I think it's in auto mode right now. Yeah. Yeah, yeah, that's what I thought. Yeah, it's not going to be able to read anything. It's basically just like, shorten these two leads together. So, yep, this guy is definitely the culprit. So it's a 35 volt, 220, 2200. I'm sorry, 2200 microfarad cap. Um, well, I certainly don't have any three-legged caps. Um, both, I don't have them here or at the lab. I might have, a two lead radial cap of this rating and voltage rating and capacitance, or at least close to. But yeah, let me see what I've got. All right, so the only thing I have that's even close is this 2200 microfarad 25 volt electrolytic. So, I mean, it is within the voltage that we're working with, but I mean, you generally you do want to go higher. I think I'm just gonna pop this in just to see if it, you know, makes a difference, or at least just for troubleshooting purposes. I know I have something at the lab that is much closer to the original, and I mean this is the correct capacitance, but I have something that would be a higher voltage rating suitable for long-term use. But I think I'll pop this in now just to see what we get. Okay, so I've got that capacitor, that replacement cap installed on the control board, and then I've got everything connected again, and I think we're gonna try to power it up, see if anything starts smoking, and then after that we'll try to test for the bias voltages, see if they're there, the bias supply voltages. Alright, so let's give it a go. Okay. Now I heard a relay click, which we hadn't been hearing before. I'm almost positive there was never any relay click before. I think that's a good sign. I guess the front panel doesn't power on when you're in test mode, which we still are. And I'm not seeing any smoking going on. So let's sorry, that's my dog snoring. But I don't know if you guys can hear that, but I'm going to put the camera on the tripod, and then we'll test some voltages on that J3 connector on the control board. All right, so as I was setting the my phone on the tripod, I could have sworn I saw some smoke coming from the main board again, but I think I was wrong. I'm not smelling anything that burnt semiconductor smell like we were smelling before. That's not there. It was pretty noisy initially, and then it's quiet right now. The sound that you're hearing possibly is just my oscilloscope, the fan going, but yeah, it seems to be okay so far. And so yeah, let's try to test some voltages on that J3 connector on the control board. So got my meter, trying to get my meter in the shot so you guys can see. But yeah, we'll start with the bias supply voltages first. So let's start with +5. Okay, so that's good. Let's do plus 15. $14.8. Okay. And let's do minus 15. It's not easy to probe this connector. Yeah, so minus 14.9. All right, so the bias voltages are all there. And we can check the reference voltages, 0.5 and 2.5. Now they have a different common pin. That's pin 9 on the connector. So let's see. 3, 5, 7, 9. So that's 0.5. Yeah, sorry, I can tell my hand is kind of causing the meter to go out of focus. 5, 7, 9. And there's 2.5. All right. So yeah, all of the reference voltages and the bias supply voltages seem to be okay. I mean, a little bit out of spec it looks like on the minus and plus 15, but the 5 volt is bang on. So I think what I'm going to do is put it into normal mode and just see what happens, and then kind of go, you know, we can see what happens, and then based off of that maybe we can, you know, do some performance checks or calibration, whatever. I haven't looked at the whole service manual to see what's, you know, available, but yeah, we'll just go from there. Alright, so I've switched it back into normal operation mode, and connected my isolation transformer to the line and neutral outputs in the back of the supply, which would connect to this EMI filter. I did hook up the fan, so that's really the only thing that's missing is the EMI filter. One other thing I found out is that I accidentally had this connector swapped the wrong way, which is probably could be why the display wasn't on even in test mode, but we're about to find out. I was looking at some previous the other segments that I had filmed for this video and noticed that it was actually, yeah, it's I had it swapped the wrong way. So anyway, the isolation transformer is on, so let's power this guy on, see what happens. Oh wow, okay. Well, that might be a good sign, right? Okay, so that works. Very nice. Not sure what the display settings button does, but, or this button. Yeah. Check that out. Okay. Well, that's a good sign. Yeah, so, you know, I think this might be a good spot to stop. We're obviously not in the clear yet, but I think we'll save this for another video of doing some testing on the supply. I really would like to make sure that that control board is okay. We did confirm that the bias supply voltages and the reference voltages are there. They seem to be close enough in spec. But yeah, just there is another electrolytic cap on that board I want to check, and just a few other things. Make sure everything looks okay, and then also, of course, replace that cap that is, we just put in to see if it would resolve the issue. We'll put in a cap that is more suitable for the correct voltage rating. But yeah, so we'll save all that for another video and stop here. But so far so good. This is a good sign, and I hope you guys enjoyed that and found it interesting. But have anything to add, leave it in the comments. Anything I did wrong or should be doing better, of course. And I'll catch you guys next time. All right.